NEC 240.21b5 addresses specific requirements for feeder taps. A feeder tap is a conductor or set of conductors that branch off from a larger feeder conductor to supply power to a smaller load or panel board. The primary concern with feeder taps is ensuring adequate overcurrent protection and conductor ampacity to prevent overheating and potential fire hazards. NEC 240.21b5 allows for specific feeder tap rules to be applied under certain conditions. It's important to understand these conditions to ensure compliance with the code. One of the core requirements stated in NEC 240.21b5 is that feeder tap shall be sized in accordance with 215.2 for the actual load served. This means that the ampacity of the tap conductors must be sufficient to carry the load they are intended to supply. This is calculated using the methods outlined in NEC 215.2, which involves considering the non-continuous and continuous loads served by the tap. The code also dictates that in no case shall the feeder taps be smaller than the minimum circuit ampacity specified in 210.19 for conductors supplying the load. This provides a lower limit on the size of the tap conductors, ensuring they are never undersized relative to the potential load. NEC 210.19 deals with the ampacity of conductors for branch circuits and provides specific requirements based on the type of load being served. When determining the required ampacity of feeder tap conductors, it's crucial to consider all applicable correction and adjustment factors. These factors account for conditions such as ambient temperature, the number of conductors in a raceway, and the type of insulation used. Failure to apply these factors correctly can result in undersized conductors that are not compliant with the code. In a scenario where there are 470 amp, one-phase number 3 feeders, the minimum circuit ampacity for these conductors must be determined. Referring to table 310.16 in the NEC, the ampacity of number 3 copper conductors is typically 75 amps, assuming a 75 degrees Celsius insulation rating and standard installation conditions. It's important to consult the specific insulation rating of the conductors being used and apply any necessary correction or adjustment factors based on the installation environment. If the conductors are installed in a manner that requires dirting, such as in a high-temperature environment or with multiple conductors bundled together, the allowable ampacity will be reduced. The feeder taps must be sized in accordance with NEC 215.2, ensuring they can adequately carry the intended load. Furthermore, they must not be smaller than the minimum circuit ampacity specified in NEC 210.19a, which in this case is determined by the ampacity of the number 3 conductors. In addition to the individual tap conductor sizing requirements, it's important to consider the total load served by all the feeder taps. The total load must not exceed the ampacity of the main feeder conductor. In a scenario where the total load served by the feeder taps is 400 amps 4 multiplied by 100 amps, this total load must be less than the ampacity of the feeder, which in this case is 225 amps. This is because the calculation states that the total load is 4 multiplied by 100 amps, and if the overcurrent protection device is rated more than the calculated load, the next standard overcurrent protection device can be used. This is important to ensure that the feeder is not overloaded, which can lead to overheating and potential fire hazards. NEC 215.2a3 addresses the requirements for feeder overcurrent protection. This section states that the overcurrent protection device for the feeder must be sized to protect the feeder conductors against overload. The size of the overcurrent protection device must not exceed the ampacity of the feeder conductors, unless the feeder conductors are sized according to the tap rules. When applying the tap rules, the overcurrent protection device for the feeder can be sized larger than the ampacity of the tap conductors, provided that the tap conductors are protected by an overcurrent protection device at their point of supply. This is typically accomplished by using fuses or circuit breakers at the tap location. Understanding the specific requirements outlined in NEC 240.21b5 is crucial for ensuring safe and compliant electrical installations. It's important to consult the latest edition of the NEC and seek guidance from a qualified electrical professional when designing and installing feeder tap systems. Attention should be paid to conductor ampacity, overcurrent protection, and load calculations to prevent electrical hazards and ensure the reliability of the electrical system. Conductor ampacity refers to the maximum current that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by factors such as the conductor material, size, insulation type, and insulation environment. The NEC provides tables that list the ampacity of various conductors under different conditions. It's crucial to select conductors with adequate ampacity to handle the expected load and prevent overheating. Overcurrent protection is the use of devices such as fuses and circuit breakers to protect electrical circuits from excessive current flow. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. The NEC specifies the requirements for overcurrent protection in various electrical systems. It's important to select overcurrent protection devices with the appropriate rating and characteristics to protect the electrical system effectively. Load calculations are used to determine the total electrical demand of a building or electrical system. Load calculations involve adding up the various loads, such as lighting, appliances, and equipment, and applying demand factors to account for the fact that not all loads will be operating simultaneously. The NEC provides guidelines for performing load calculations. Accurate load calculations are essential for sizing electrical services, feeders, and branch circuits. When dealing with feeder taps, it is also important to consider the length of the tap conductors. The NEC places limitations on the length of tap conductors to prevent excessive voltage drop and ensure adequate overcurrent protection. The specific length limitations depend on the size of the tap conductors, the ampacity of the feeder conductors, and the type of occupancy. It's important to consult the NEC to determine the allowable length of tap conductors in a specific application. In addition to the requirements for conductor ampacity and overcurrent protection, the NEC also addresses the grounding and bonding of feeder taps. Grounding and bonding are essential for providing a safe path for fault current to return to the source, reducing the risk of electric shock. The NEC specifies the requirements for grounding and bonding in various electrical systems. It's important to ensure that feeder taps are properly grounded and bonded in accordance with the NEC requirements. Furthermore, the NEC also addresses the identification of conductors and feeder tap systems. The NEC requires that conductors be identified by color coding or other means to indicate their purpose. This helps to prevent confusion and ensures that electrical systems are properly installed and maintained. It's important to follow the NEC requirements for conductor identification in feeder tap systems. The NEC is a comprehensive set of standards that covers a wide range of electrical topics. It's essential for electrical professionals to stay up to date with the latest edition of the NEC and to understand the specific requirements that apply to their work. Failure to comply with the NEC can result in electrical hazards and legal liabilities. Understanding the NEC requirements for feeder taps is crucial for ensuring safe and compliant electrical installations. It's important to consider all applicable factors, such as conductor ampacity, overcurrent protection, load calculations, tap conductor length, grounding and bonding, and conductor identification. By following the NEC requirements, electrical professionals can help to prevent electrical hazards and ensure the reliability of electrical systems. When working with electrical systems, it's always important to prioritize safety. Electrical work can be dangerous, and it's essential to take precautions to protect yourself and others from electrical hazards. Some basic safety tips include wearing appropriate personal protective equipment such as gloves and safety glasses, de-energizing circuits before working on them, and using insulated tools. It's also important to be aware of the potential hazards associated with electricity, such as electric shock, arc flash, and arc blast. By following these safety tips, you can help to reduce the risk of electrical accidents. The feeder taps are 470 amp, one-phase number 3 feeders. According to Table 310.16, the minimum circuit ampacity for these conductors is 75 amps. Therefore, The feeder taps are sized in accordance with NEC 215.2 and are not smaller than the minimum circuit ampacity specified in NEC 210.19a. Additionally, the total load served by the feeder taps is 400 amps 4 multiplied by 100 amps, which is less than the ampacity of the feeder 225 amps. Therefore, the feeder taps are also in accordance with NEC 215.2a3. Therefore, this installation is allowed under NEC 240.21b5. It's also important to verify the interrupting rating of the overcurrent protection devices is adequate for the available fault current at the point of application. Available fault current studies are used to determine the magnitude of fault current at various points in the electrical system. This helps to select overcurrent protection devices with sufficient interrupting rating to safely clear fault currents. Insufficient interrupting ratings can lead to equipment failure and potential safety hazards. In addition to overcurrent protection, surge protection is another important aspect of electrical system design. Surge protection devices, or SPDs, are designed to protect sensitive electronic equipment from voltage surges caused by lightning strikes, power grid switching, or other transient events. SPD are typically installed at the service entrance and at critical branch circuits. The NEC provides requirements for the installation of SPD. It's important to select SPD with appropriate voltage and current ratings to protect the equipment effectively. Furthermore, coordination studies are performed to ensure that overcurrent protection devices operate in a coordinated manner. Coordination studies involve analyzing the time current characteristics of different overcurrent protection devices to ensure that the device closest to the fault clears the fault first, minimizing the impact on the rest of the electrical system. Poor coordination can lead to unnecessary outages and equipment damage. The NEC provides guidelines for performing coordination studies. Energy efficiency is another important consideration in electrical system design. Energy-efficient lighting, motors, and other equipment can help to reduce energy consumption and lower utility bills. The NEC provides requirements for energy efficiency in various electrical systems. It's important to select energy-efficient equipment and to follow the NEC requirements for energy efficiency. Also, power quality refers to the characteristics of the electrical power supply, such as voltage stability, frequency stability, and harmonic content. Poor power quality can cause equipment malfunction, damage, and reduce efficiency. Power quality monitoring and mitigation techniques can be used to improve power quality. The NEC addresses power quality issues in various electrical systems. The ambient temperature surrounding electrical equipment can affect its performance and lifespan. High ambient temperatures can reduce the ampacity of conductors and the rating of overcurrent protection devices. The NEC provides correction factors for adjusting ampacity and ratings based on ambient temperature. It's important to consider the ambient temperature when designing and installing electrical systems. Voltage drop is the reduction in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of electrical systems. The NEC provides guidelines for limiting voltage drop in various electrical circuits. It's important to calculate voltage drop and to select conductors with adequate size to minimize voltage drop. Harmonic distortion is the presence of harmonic currents and voltages in an electrical system. Harmonics can cause equipment overheating, malfunction, and reduced efficiency. Harmonic filters can be used to reduce harmonic distortion. The NEC addresses harmonic distortion issues in various electrical systems. In industrial facilities, it's common to use motor control centers or MCCs to control and protect electric motors. MCC typically include motor starters, overcurrent protection devices, and control circuitry. The NEC provides requirements for the installation and wiring of MCC. It's important to follow the NEC requirements when working with MCC. For hazardous locations, such as those containing flammable gases or vapors, special electrical equipment and wiring methods are required. The NEC provides requirements for electrical installations in hazardous locations. It's important to use equipment that is specifically listed for use in hazardous locations and to follow the NEC requirements for wiring methods. Electrical systems should be inspected and tested regularly to ensure that they are operating safely and efficiently. Inspections and testing can help to identify potential problems before they lead to equipment failure or safety hazards. The NEC provides guidelines for electrical inspections and testing. It's important to schedule regular inspections and testing and to address any problems that are identified. Proper documentation is essential for electrical systems. Documentation should include drawings, specifications, and test reports. Good documentation can help to ensure that electrical systems are properly installed, operated, and maintained. The NEC provides requirements for documentation of electrical systems. It's important to maintain accurate and up-to-date documentation. Understanding the NEC requirements for feeder taps is crucial for ensuring safe and compliant electrical installations. It's important to consider all applicable factors, such as conductor ampacity, overcurrent protection, load calculations, tap conductor length, grounding and bonding, and conductor identification. By following the NEC requirements, electrical professionals can help to prevent electrical hazards and ensure the reliability of electrical systems.